In this video, we'll be looking at the test for some common gases. By the end, you should be able to identify the different types of gas collection, and you should be able to describe the gas tests for hydrogen, oxygen, carbon dioxide, and chlorine gas. There are various ways by which we can collect gases. We're going to be looking at three. Now, the first method is the upward delivery. This is where we collect gases that are less dense than air, for example, hydrogen gas. The first diagram to our left, this is what we call upward delivery, where the gas, because it's lighter, it's collected at the top of the tube. Now, with the middle diagram, this method is called downward delivery. This is where we collect gases that are more dense or the same density as air, for example, carbon dioxide. And finally, the gas syringe method, we use this when it is we want to collect a known volume of a gas, for example, in quantitative analysis, when we want to determine the amount of gas collected from a reaction. The main thing that you need to note is that different gases, they have different densities, and this is why we have different methods of collecting gases. Before I begin describing the gas tests, I want you to pause the video and create this table. As it is I'm doing the different gas tests, I want you to write the method for the test, the observation, and the possible sources of error. We can test for hydrogen gas using a lit splint near the top end of the container that you are collecting the gas in. For example, the top end of our test tube. Now, if you hear a squeaky pop sound, this is a positive test for hydrogen gas. I want you to pause the video and think about possible sources of error that might occur when you're trying to collect this gas. Well, some gas may escape before it can be collected in the upturned test tube, and as a result, you might not get a positive test if all the gas has managed to escape. In this test tube, I have hydrogen gas. I'll be using a burning splint to test for the presence of the gas. There we go. With hydrogen, we get a pop sound. When testing for oxygen, you can also use a splint, but this time it's a glowing splint that's needed. Now, to produce your oxygen, you can add manganese oxide to about 15 centimeter cube of hydrogen peroxide and just put the glowing splint down into the conical flask. What should happen is that your glowing splint should be relit. Now, the sources of error would be similar to when we were testing for hydrogen by upward delivery. You can also collect oxygen by upward delivery or a method known as water displacement. The source of error, the gas could escape as it's being collected. Our next test will be the test for oxygen. I'm going to be using a glowing splint. Notice what happens. Oxygen relights the splint. Let's try this again. It's glowing, and here we go. It relights it. Okay, to test for carbon dioxide, I'm going to be using lime water. Now, lime water is an aqueous solution of calcium hydroxide. So I'm going to pour my lime water into the test tube. The color of lime water, it's actually colorless. It's a colorless solution. So you can see it's colorless. And then what I'm going to do is blow some carbon dioxide into this lime water. it should change to cloudy after a while. It's still quite clear. It's getting a bit cloudy. And there we go. That's how we test for carbon dioxide. We use lime water, which is aqueous calcium hydroxide, and there's a color change from colorless to cloudy white. When testing for carbon dioxide, as was shown in the demonstration earlier, we use lime water. Now, an experiment that you can do to produce carbon dioxide is reacting dilute hydrochloric acid with marble chips or calcium carbonate. This will produce carbon dioxide. Now, if you notice in this diagram, the method of collection is downward delivery. Now, the lime water should change to a milky or a cloudy color. Think about a possible source of error that can occur while you're doing this test. Well, if it is the tube passing the gas from the reaction test tube to the lime water test tube, if that tube is not fully inserted into the lime water, the gas could escape and we won't get a positive test for the reaction. Our final gas test will be testing for chlorine gas. Now we're going to be very careful with this because, as you can see, it is toxic and it is an irritant as well. Now to do this test, we're going to need blue litmus paper. So we're going to be using blue litmus paper. What I'll do is put this litmus paper at the top end of the test tube and then observe for any color change. Okay, so after a while, that should change to pink and then it's bleached to a white color. Hopefully that's clear enough for the camera. Yep. So at the beginning, the litmus paper looked blue, then gradually changed to like a pinkish color, and now it's totally white. When testing for chlorine gas, as shown in the demonstration earlier, we use blue damp litmus paper. A positive test will turn the blue litmus into red and then eventually bleaches it into white. Now, a possible source of error, if it is your litmus paper isn't damp, you might not see that red color because the water needs to react with the chlorine to form an acidic solution, allowing the litmus to change to that red color. Eventually, the chlorine gas will bleach it, turning it into white. Here's a summary of the tests that we conducted earlier. They're in a different order, but the same tests nonetheless. Chlorine gas, it turns blue damp litmus paper into red and then bleaches it into white. Oxygen relights a glowing splint. Hydrogen, it gives a squeaky pop sound with a lit splint, and carbon dioxide turns lime water milky or cloudy.